Well, hi there, guys. Today we are dealing with 6.4. Just outside as an FYI, I will be doing Chapter 7 stuff in the next few days. There is only one assignment in Chapter 7. It covers all of Chapter 7, so it's a little lengthy. Do not wait till the last minute to do Chapter 7. But I do know this section, 6.4, and then Chapter 7 aren't due until the first week of May. So you got a lot of time to actually work through that. As soon as we get done with 7, that due date, you'll have your last test, which again will be on your my math lab. It's a little shorter. You'll probably have a little less time to do on the test, but I'll get you information on that when we get there. So anyway, 6.4, blah, 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 blah. I guess I'm doing this too early in the morning. 6.4 is proportional reasoning, okay? Things we're going to be doing. We got to talk about ratios, proportions. We already know what a ratio is. We'll talk how they work in a proportion. We got to figure out how to find a constant of proportionality and scaling. There's bar models at the end. We're probably not going to hit a lot of that. I do know most of the classes you have aren't going to have that as much. So a ratio, okay? So we know what a rational number is. We got to now know what a ratio is. A ratio is used to compare two things. Okay, two couple different ways you can write this. It's usually written as a over b, common one, or a to b. Okay, sometimes you'll have it as the word to b, and that's okay too. Okay, and the reason you'll have that one a lot of times is you'll have it representing as part to part, part to whole, whole to part. Okay, so in essence, one of the other ways you could do things is by saying A to B. Okay? So that is another way that can be written. Okay, so what we're talking about is part to part, part to whole. Okay, to give you another thing, we can say 5 to 8, which means 5 out of could be 5 to another part. You know, part of this and part of that should be 5 to 8, boys and girls or something like that. Could be 5 could be the part and 8 could be the whole, which will leave you 3 left over, something like that. Okay. You can also do 8 to 5, or that would be 8 divided by 5, right? So any of those would actually work also. All right. So let's go ahead and keep it going. All right. So where we're talking about this, where there were 7 males to 12 females in the Dewdrop Inn on Monday evening. In the game room next door, there were 14 males and 24 females. Express the number of males to females in the end at the ratio. Okay, so part to part. Okay, so we're talking about males to females. Okay, so we're looking at 7 to 12 that are in the end. Okay, express the number of males to females in the game room. 14 to 24. And after we do that, when we give a final answer, we will make sure to reduce. And it says or, depends on how the question might be asked for you. Okay, but reducing is always a good thing. Okay, there are 7. Here's the same problem. Express the number of males in the game room to the number of people in the game room. So how many males in the game room? 14. There are 24 females, but how many people? Okay, this would mean all these males and females are people, right? And not male dogs or male cats or whatever the case may be. So we'd have 14, and how many total people there would be 38. So I'd get 14 over 38, or 17 over 19, or 17 to 19 as a final. All right, so now that we know what a ratio is, we're going to use that in terms of what we call a proportion. Okay, and if you notice, the ratio was all rational numbers. Okay, it can also be improper or proper fractions that we talked about. Now, in a proportion, okay, is a statement that has two, whoops, I can do this. Nope, not gonna let me do it today. Okay, so in that proportion, it is a statement that two given ratios are equal. Okay, now remember, this ratio means it's a rational number. Okay, so by definition, if A, B, C, D are all real numbers, B and D can't be 0. That's just because of the formula here, or the rule that they're giving B and D on the bottom. Then the proportion is true if and only if AD times BC is equal. Okay, now if I have this ratio and I say it's equal to this ratio, it only works as if these two, when you multiply them, is going to equal to these two, the old cross multiplication. And this is how we show if two ratios are in a true proportion. Okay, such as if I have 4 over 7 is equal to 8 over 14. How do I know? 7 times 8 is 56. 14 times 4 is also 56. So that means this was a true proportion. Okay. All right. All right, Allie and Binti, here's an example. Type the same speed. Allie started typing first. When Allie had typed 8 pages, Binte had typed 4 pages. Then Binte had typed 10 pages. How many had Allie typed? So we know at the first rate, you're going to have, I guess let's do it this way. Okay. So we have this example of an additive relationship, okay, in which we can actually set up a proportion. Okay, so students should reason that the two people type the same speed. That's because they tell you that. Okay, so if we talk about, okay, they typed 8 pages and 4 pages, so Allie would be 8 over 4. Okay, when Binte has typed 10, so Binte was on the bottom. So as we set our proportion, Binte would go on the bottom at 10. How many had Allie done? Okay, so as you to solve this proportion, what they're saying is this: the additive property, let's do this here, means that if I add 6 here, that means I have to add 6 here because they're typing at the same speed. Okay, because when they first started, this is where they were at when they first started, which means 4 plus 6 is 10, and then 8 plus 16 would be, she will be at the 14th page at that point. Okay. Okay, Carl can take 8 pages for every 4 pages Dan can type. If Dan has typed 12 pages, how many has Carl typed? So here is multiplicative for using multiplication, easier to say. All right, so what we're saying is Carl can do 8 when Dan can do 4, which means they type at different rates. If Dan has gotten, Dan is the bottom, these are Dan, okay? How many will Carl be at? Now notice this ratio. This would also be the same as if I said 4 over 8 is equal to, and now 12 has to go with the 4. These are the same proportions. They will solve the same way. So in this process, using multiplication, wouldn't I be, to get from 4 to 12, I'd multiply by 3. That means if I multiply this by 3, I'm going to get 24. Okay, same thing here. Multiply by 3, multiply by 3, I'd get 24 here. Okay. That's where we get to the 24. All right. There are 3 cars for every 8 students at the high school. How many cars is there if there's 1,200 students? Okay. So, I wish I did this a little bit differently. They had it all there. So we have cars to students. 3 to 8 is equal to x over 12. Now, you could try and figure out, what do I have to multiply to 8 to get to 1,200? Yeah. Okay. But because if we're saying this is a proportion, we know that these two have to equal what these two multiply. And then I can solve algebraically by multiplying these two together. I get 8x here, divide by 8, and I get 450. And that would be, how do I know what that 450 goes with? Here's the x. That means it's labeled with the cars, so it'd be 450 cars if that was a proportional deal. Okay. All right, so constant of proportionality. If the variables of x and y are related, then y equal kx, or k is equal to y over x, then y is the proportional to x, and k is the constant of proportionality. Okay, so we use that to help in what we call scaling. It says the central idea of proportionality reasoning is such that the ratio between two quantities is such that the ratio of one quantity to the other remains unchanged. Okay, so the scaling strategy. Okay, and this is really good for your kids, especially at the younger level. They can handle a lot of this. Okay, use a scaling strategy to determine which is the better buy. 12 tickets for $15 or 20 tickets for $23. So there's a couple of different methods that are out here. The scaling strategy uses the LCM, okay, which you tested on last time, or the least common multiple. Okay, and what we do for the value is we want to figure out a common multiple of the tickets. Well, I have 12 tickets and 20 tickets. The least common multiple between 12 and 20 is 60. So if we figure out how much 60 tickets is going to cost us for both this pricing and this pricing, we can tell which one's better. All right. So how do I deal with that? Well, how do I get from 12 to 60? I'd have to multiply by 5. Okay. So where's my thing? Here we go. So to get from 12 to 60, you got to multiply by 5, which means I'm going to multiply the 15 by 5, which means that 60 tickets for the first strategy is going to cost me $75. Okay, how do I get from 20 to 60? We got to multiply by 3. So that means we got to multiply this by 3. 23 times 3, which would be what, 69? So which one's going to be the better deal? Well, that means this one has to be the better deal. Okay. All right, so let's look at that. Okay, so that's just showing how that. So the second plan is the better buy. Okay. Now, here's a very common thing, and if you go to HEB, you'll see this. is what they call the unit rate. Okay, and instead of trying to figure out what your common multiple is, we're going to see what the price of one ticket is. Okay, so if I find the price of one ticket, if I buy 12, and one ticket if I buy 20 at 23, what's my deal? So how would I do that? Well, I'm not going to multiply it to 20, or I can't multiply anything to 12 to get to 20 except for fraction. Easier to take the 12 and divide it by 12 to get 1. So if we take the 12 tickets and divide by the 15 divided by the 12, each one's going to cost 125. If I take the 23 and divide by 20, you're going to get $1.15, which again makes the second plan the better deal. Okay? So one's using multiplication, one's using division. Okay? And you see that in HEB all the time. All right, so I do know there's a homework question. I think even a test question like this one, so you want to make sure you like this one. We have 3 people, okay? They made $2,520 for painting a house. Kai worked 30 hours, Paulus worked 50 hours, and Judy worked 6 hours. They divided the money proportionally amongst them, okay, for how much they work. How much did each of them earn? Okay, so how are we going to deal with this? Well, because we know how much they work, and your pay is always the number of hours times how much you get paid per hour. That's what we got to figure out, okay? So if it's proportional, we got to deal with each of these numbers. So it says let X be the unit rate they were paid per hour. So that would mean Kai would get 30 times X for how much he received. Okay, and he'd do the same thing for Paulus, 50 times X, Judy times X. Okay. And so that's going to help us set up these ratios, 30 to 50 and with 60. Okay, so if it's just 2 people, you'd have a ratio of 30 to 50. Now we add the third one with the 60. So now you're going to have total amount received is going to be 30x plus 50x plus 60x, which is going to equal the 2,520. Okay. Now you're going to add the x's together, get 140, and we're going to divide by x. X is our unit rate. In other words, how much they were getting paid per hour. Now, how do you tell how much they get paid? Take your unit rate times the hours they worked. So 30 times 18, I got 540. Paulus got 900 because 50 times 18. And Judy received 1,080 because she worked 80 or 60 hours, so she got more money. All of that should add up to your 1,200, 1,250, whatever it was. Okay. All right. So proportion again. If and only if. Well, this is A. It's a proportion if A over B is equal to C over D. If you can cross multiply. You can also say if you can flip them. Okay. Now this is a rule that a lot of people don't get. Okay, and that I use a lot in algebra as they get older. Okay, and what I mean by that is this following. All right, if you take a ratio such as 4 over 5, well, let's do this. Let's do it easier. Okay, would you agree that 2 over 4 is equal to 1 over 2? I think you all would, right? What this says is if this works, then 4 over 2 would have to equal 2 over 1, which we know also is true, right? They both work. Now, where does this come in handy? Well, it comes in handy if I have something like 3/5 is equal to 1 over x. Well, if I know that's equal, and I'm trying to solve for x, okay, couldn't I flip the 1 over x to become x over 1? and then flip these to be 5 over 3. And isn't that solved for x now? So it's a quick way of solving without actually having to do any other work. Okay, or if your x is on the bottom, you can flip it and you get your x on the top. Okay, a lot of things make things easier like that. Okay, and I use that a lot in a lot of algebra technique. Okay, scale drawings. Okay, here's where you're going to use a scale drawing in which you got to find the ratio. Okay, now in this problem, we have is a floor plan, and it says find the dimensions in meters. Okay, so they don't give a whole lot. They really need to give a little bit more information on this problem, but we're going to take it apart and assume we know what they're talking about. If they give us this scale, okay, this would probably mean for every 1 meter, okay, it's going to be, or it's kind of weird. This would have to be for every centimeter, you would get this many centimeters. Okay, now we'll talk about meters in a minute. I'm trying to, that they really need, when you give your scale, you need to put its units with it somehow or another so you know what your units are going to. Okay, but 1 to 300 couldn't be meters because that would be a really big building. All right, so we're going to take this. We need to find the dimensions. So this is your map scale or your blueprint. We want to know how big we got to make this living room. So for every 1, so we're going to take our unit ratio or scale, we're going to multiply this by 300. Okay, and then we're going to multiply this by 300. Okay, so we're going to take our numbers, and so take my calculator times 300. Okay, so this side over here is going to be, we're going to build it this many centimeters. Okay, and then we're going to build this one this many, 750 centimeters. All right, so now what we need to know is we have to know how big this is going to be in meters. All right, so over here, okay, how do I figure out how many meters? Well, if I have 750 centimeters, we can divide that by 100 centimeters in a meter, okay, which means this is going to be 7.5 meters. Okay, and then we're going to take this one, and we're going to take here, and this is going to be 11.1 meters. And there is your dimensions in meters in your living room. Now, how would I write that? Well, we'd go over here, and we do 7.5 meters by 11.1 meters. And that would be your dimensions to that problem. Okay. And that's how big it would need to be. And I remember a meter is close to a yard. So you're looking at something, if you want to change it to like close to feet, times each of those by feet. So that's a pretty dang big living room. You're looking at 33 by 23, basically. Not a bad size. Okay. So, and then you have this bar ratio. Whoops. Sorry about that. My bar ratio, put that back in there again. All right. So bar ratio. Sorry about that. Okay, uses this. I'm not a big fan of it, but you can still get your ratio of your 3 to 11. You can kind of look this one over as a secondary system. All right, so that is the end of chapter 6. Hope this